Next, we're going to take a look at a geometric sequence, and this is a sequence that has a common ratio or a common multiplier. So our explicit formula, similar to the explicit formula for an arithmetic sequence, we've got the nth term equals the first term, and this time instead of adding like we do in an arithmetic formula, we multiply by the common ratio to the n minus 1 power. The recursive formula, similar to the recursive formula for an arithmetic sequence, we need to know what the first term is, and then we can take that term, multiply it by the common ratio to get the next term. So we'll take a look at how these formulas work. First of all, we are going to show that the sequence is geometric. Unlike an arithmetic sequence where we just add or subtract a value, it's fairly straightforward to figure out. With a geometric sequence, sometimes that common multiplier can be a fraction. So the best way to find that common ratio is to take the second term, divide by the first term, so set up that ratio, and see if that ratio equals the third term divided by the second term, which should equal the fourth term divided by the third term. Now this one's fairly straightforward. When we divide each of these, we get 2. So 2 is our common ratio, and because that ratio is equal, it is a geometric sequence. Next, we're going to take a look at that explicit formula. So we're given our formula as the nth term equals the first term times that common ratio to the n minus 1 power. The nth term equals that first term times the common ratio. Now in this one, it's not as straightforward as multiplying by 2, so I'm just going to go ahead and set up 100 over 250, and then we'll simplify that for our common ratio to the n minus 1 power. So simplifying that common ratio, we get 2/5 to the n minus 1 power. So there's our explicit formula. And the next piece, we were asked to determine the seventh term. A sub 7 equals 250 times 2/5 to the 7 minus 1 or 6th power. So we get 250 times 64 over 15,625. And when we simplify this, both 250 and 15,625 are divisible by 125. So we get 2 times 64 over 125, which gives us 128 over 125. And I do want you to get comfortable using fractions, so simplify your answer, give them as fractions instead of just punching buttons on your calculator and giving me a decimal. Finally, for this video, we're going to take a look at the recursive formula. First, we're going to list the first 4 terms. So our first term is 18, and our recursive formula tells us to multiply the previous term by 4/3. So multiplying 18 by 4/3, we get 6 times 4 is 24. I divide before I multiply. So if you are someone who is not as comfortable with fractions, when you take a whole number and multiply it by a fraction, remember the fraction bar means divide. So what I'm doing is I'm taking 18 and I'm dividing it by 3 to give me 6, and 4 times 6 is how I'm getting my 24. So I'm going to do that again. 24 divided by 3 is 8, times 4 is 32. Now 32 does not divide by 3 evenly, so we are going to end up with a fraction on this one. 32 times 4 gives us 128 thirds. For our first 4 terms, determining the common ratio, we can simply look at the recursive formula. We were multiplying by 4/3, so that's our common ratio, and use that to write the explicit formula. So we have a sub n, our nth term, equals our first term times the common ratio to the n minus 1 power, and that's our explicit formula.